In our example, we have a car that gets 20 miles per gallon of gasoline, and Darren starts out with a full tank, and in his particular car that's 16.4 gallons. And as he drives, he watches his gas gauge to see how much he has left. Part A is asking us to identify the independent and dependent variables. Remember that the independent variable always influences the dependent. So the dependent one relies on the independent. So the two things we're looking at are the miles driven and the gallons of gas in Darren's tank. So you have to think about which one influences the other. Okay? The miles we drive is going to influence the gas level. So that means that X is going to be our miles driven. And whenever you are defining independent and dependent variables, you always want to include units. So our Y is gallons of gas remaining in tank. Okay. B is asking us to state a reasonable domain and range. Okay. Well, remember our domain is our X values and our range are our Y values. Okay, and X for a reasonable domain, okay, we know that we start with 16.4 gallons before we start driving. So that means that we're starting with 0 miles. Okay? And we don't want to think about once we use up all of our gas. Okay, there's no such thing as negative gallons of gas. So we only want as many miles as our gas tank will take us. So if we have 6.4 gallons and 20 miles per gallon, that means that we can, for every one of those 6.4 gallons, travel 20. So if we take 20, multiply that by 16.4, we get 328. So that is going to be our maximum domain. Our range, we are thinking about gallons of gas, our Y values. We know we start with 16.4, so that's going to be our maximum. Our minimum is going to be when we run out, which would be 0 gallons. So that would be 0 to 16.4 gallons. Now, C asks us to write a linear equation in intercept form to model the situation. Okay, so we have a couple of important pieces of information. The 16.4 are our starting value. That's going to be our y-intercept. The 20 miles per gallon we're going to use to help us find our slope. The only problem with the 20 miles per gallon is our units are flip-flopped from what we need in our equation. So if our x values are miles driven, we need our slope to be gallons per mile. So we're taking that 20 miles to 1 gallon, and we are going to flip that to 1 gallon per 20 miles. Now we have the information we need. We've got y equals 1 over 20 x plus our starting value, which is 16.4. Now the only problem with this is we would have ourselves adding gas to our gas tank, which we know that's not how it works when we drive. We are losing gas as we drive. So this is a negative 1 over 20x plus 16.4. Okay. D asks us how much gas will be left after 175 miles. First thing we need to decipher is what that 175 is, if it's an x value or a y value. We can always tell by our units. Miles, we know, we've already defined our units, is x. So for D, all I have to do is take the equation I just wrote and plug 175 in for x. Go ahead and do that now and get yourself a gas level, and make sure you include units. Once you have finished there, you can move on to E. E is asking us how far he can travel when he has less than 2 gallons remaining. So for that problem, we are plugging in 2, and since our unit is gallons, that is our y value. So that will be two equals negative 20, 1 over 20, sorry, times x plus 16. Okay. And then all we need to do is solve for x. We should subtract 16 and then multiply by negative 20 to undo our fraction, and that will give you the amount of miles that need to be driven to reach 2 gallons.